Hello, Algebra 2. This is Mr. Eichen. We're looking at 7.6, a section of 7.6 notes today. And today we're going to use the idea that you can solve equations using same bases, and we're going to apply it to solving logs. So you might find that on some of these, you can use the idea of logs undoing exponents to get the answer. But another way you can do it is by rewriting it as exponential equations and solving them that way. So let's begin here. On example 1, it says log base 1/7 of square root 7. And I'm going to rewrite this as an exponential. So I'll put equals x, or you can say equals question mark. And we're going to rewrite this. We're going to rewrite it as 1/7 to the x power equals square root 7. And I'm going to solve this by getting the bases to be the same. Now when I look at this problem, I see these 7s and I'm thinking I'm going to rewrite both of them as base 7. So if I write 1/7 as a base 7, the exponent has to be negative. And I've got that x up there, so I'm just going to make it negative x. The square root 7, square roots we've learned are actually exponents of 1/2. And now that we've got our bases the same, we've learned that you can basically ignore the bases and just set negative x equal to 1/2, multiply or divide that negative over, and we get an answer of negative 1/2. And there you have it. Let's try another one. Example 2, let's rewrite it. Our base is 3, so we go 3 to the x power equals, swing around, 1/81. Now this 3 I can't really rewrite very easily another way, so I'm going to leave that alone, and my challenge is to rewrite 1/81 as 3 to some power. So I know it's going to be, I know because this is a fraction, I know it's going to be flipped over. So flipping it over will get me the fraction, but then from there, I'm going to need to raise 3 to some power to get 81. And I grab my calculator. Oh, there it is, yeah. 3 to the 4th power is 81. So a negative 4 would flip it over, raise it to the power, and get you 81. And at this point, our bases are the same. And we get x is equal to negative 4. Just like so. So those problems were evaluate problems. They did not start out as equations, but we made them equations so that we could rewrite them and get them figured out. Next, let's look at some that start out as equations. And let's just get a little bit of experience. There's a lot of variability here, a lot of different types of problems you'll see. And so let's just get a taste of a few. There's quite a few practice problems here. You know, if you want to do the odds because you're cramped on time, you can do the odds. But there's quite a bit of practice here to get you familiar with this idea. So log base 4 of 64 equals x. I'm going to rewrite it. Swing it around. So base 4 of x equals 64. And let's see, I'm going to grab my calculator. I think I can rewrite 64 as 4 to some power. So I'm going to just try some things here. 4 exponent 3. Oh yeah, 4 exponent 3. 4 to the 3rd power is 64. So that's what I'm going to do. I'm going to keep the 4 over here. Rewrite 64 as 4 to the 3rd power. And just like that, before we know it, we got an answer. Now what's interesting about this is you could have said, and some of you may be thinking about this, you could have said, oh, you know what, 64, that's 4 to the 3rd power, and you could rewrite it here. And let me just show you what that would look like real quick. Don't write this down. You might write it like that and then realize, oh yeah, log base 4 of an exponent base 4, they undo each other. I'm just left with 3 on this side. And voila, 3 is equal to x. So there's 2 ways to think about this. All right, let's move on here. Next example, x to the 4th power equals 16. So this is a little bit different. The x was in a different place. But we're asked to solve this. We're not actually going to solve this by doing same bases because we've learned other ways to solve this. If I want to get x by itself, I'm going to take a 4th root of both sides. And I'm going to get x is equal to, and it turns out the 4th root is 4th root of 16. Sorry, I'm finding the button on my calculator. Is 2. 4th root of 16 is 2. So we're going to get 2. Now, if you're paying attention, you might realize that this is not the whole story. I just took an even root, didn't I? And when you take an even root to undo an even exponent, you're actually going to get 2 possible answers. So it's plus or minus 2. So you just got to be on your toes about stuff like that. All right, let's try another one a little different. 7 to the 0.5 power is equal to x. Well, what's kind of crazy about this is we're done, aren't we? I mean, we're done in the respect of x is already by itself. But what we need to do is write this a little bit nicer. I don't know, this just looks funny to me. You could punch it in your calculator. Get you a crazy decimal, so I don't want to round that. I think I want to, I know what I'll do. To make this look nice, I'll just rewrite this as 0.5 is 1/2. So I could do 7 to the 1/2 power, or if I wanted to make it look a little different, I could do x equals square root 7. Those are exact answers, and those are preferred. Moving right along. You know what I saw first on this problem? I saw base 10, base 10. I would put a little 1 up there, undo the log base 10 and the 10, and I know our answer is 1, so I kind of give it away, but our answers are going to be 1 here. But you can also rewrite it as an exponential. 10 to the x power is equal to 10. And then don't forget that if you have a base without an exponent, you can always slap a 1 up there. And we get x is equal to 1. And let's do one more together and then we'll call it quits. Well, I mean, I'll call the video quits. I'd appreciate it if you guys would work some practice problems. Let's rewrite 3/5 to the 2x power is equal to 27 over 125. Okay. Now these bases do not match, but I think I've got it. I think we can rewrite these using 3/5 as a base. It's kind of strange because we have a fraction, but not that strange. So we're going to write 3/5, and we're going to find out what power, 3/5 to what power would get us 27 over 125. Now that may seem daunting, but just focus on one or the other. Focus on the 3 to get 27, or focus on the 5 to get 125. And that'll tell you your answer. And I know it, it'll be to the 3rd power. So for some reason I decided to put parentheses this time. You should probably have it both times. But yeah, 3/5 to the 3rd power, you'd raise 3 to the 3rd power, get 27, 5 to the 3rd power, get 125. And our bases are the same, so we write 2x is equal to 3, divide that 2 over, and we've got it. So ladies and gentlemen, please practice some more. We got a quiz coming up on this real soon. Thanks so much for watching.